Let's talk about what scenery developers refer to as ground polygons, or ground polys. They're basically custom 3D models of the hard surfaces of an airport, runways, taxiways, aprons, etc. They can be concrete, asphalt, gravel, or usually some combination of these. By default, FSX, P3D, and X-Plane offer default ways to add these surfaces that are quick and easy. So why go through all the extra effort to create custom versions? Well, to put it bluntly, the default methods in all of these sims produce work that is decidedly unrealistic, not to mention being generic rather than specific to the place being modeled. And what use is it to spend hundreds of hours modeling perfectly accurate terminals if you're then going to plop them down on top of generic asphalt or concrete? What we need are hard surfaces that maintain the superior illusion of reality that our high-quality models deserve. At first glance, it doesn't seem all that hard to create a decent ground poly. I mean, after all, there are photos galore of concrete and asphalt available on the various free texture websites, right? Unfortunately, it's not quite that simple. The main challenge we have in creating great groundwork is texturing in a way that doesn't involve massive numbers of textures and thus kill performance, while still appearing to be fully custom without a lot of obvious visual repetition. And the key to walking that particular tightrope lies in intelligent layering of polys and textures. The ground polys shown here may look like a single object, but in reality they're a sandwich of several layers of repeating imagery, in which the scale and frequency of repetition has been staggered to minimize the visual patterns. So let's take a look at how it all comes together in the 3D editor. So here we are in Blender. Let's start with a high view of the layers and how they work together, and then we can get into the methods for creating the actual polys in the first place before the textures are applied. Even though all the layers will technically be on the same level, which is flat against the ground in the sim, we're going to use either the Z-bias parameters in P3D or the layer drape group param in X-Plane. Either way, the result is the same. We'll be using those options to explicitly set the order that the layers are drawn so we can build up the look we want in a controlled way. The bottommost layer, seen here, is the base asphalt. This covers all the airport hard surfaces and is there to block out any ortho imagery below and to provide a base level of fine asphalt detail that will be visible when you're close to the surface. You can see there's definitely repetition here, but it's minimal and it will be hidden by the overlay layers that we add later. The next layers are the base concrete for the aprons. There are two types of base concrete here. There's a darker and a lighter version to simulate the different ages of concrete as shown in the Google Earth view of the actual airport. Next up, we've got the layers for the two asphalt runways. With all the base materials in place, now we start adding semi-transparent overlays to break up the repetition and to provide some mid-level detail. This is a stain and general wear layer. Again, you can see there's definitely repetition here, but because we don't need the fine detail on this layer, we can scale up the textures so they're repeating at a different rate than the base textures, which makes that repetition a lot less obvious. The next layer is another overlay, this time simulating the border between the different blocks of concrete and asphalt as they were poured. It's just geometric patterns of semi-transparent light and dark areas. On top of the overlays, we introduce a layer of markings. This is everything from edge and centerline striping to whole short lines, parking designators, runway number blocks, etc. If it's a painted infographic, it's in this layer. The one exception to that rule is the next layer, which is the vehicle paths around the airport. These use a separate material for reasons I'll get into when we talk about how they're made. On top of the markings, we have a layer of semi-transparent general grime from the aircraft wheels, which is applied only to the runways. Then we add the touchdown streaks from where the tires actually contact the runway on landing. The next layer is oil stains and dirt around the aircraft parking areas. The second to last layer is specifically for edge blending our surfaces to avoid unrealistically sharp boundaries between the ground and our polys. It can be kind of hard to see, but essentially it just covers the edges where our asphalt and our concrete sort of meet with the ground. And the topmost layer is dirt and grime added to the primary movement areas, similar to how highways have darker, dirtier areas where the car tires travel than at the outer edges or the center of the road. The number of layers in this example might seem a bit extreme, and in truth you could probably get away with fewer. What I wanted to present here is sort of a worst-case scenario as far as complexity goes. Ultimately, I think all this work paid off nicely in the finished product. In this video, we talked about why to use layering for ground polys and got an overview of each layer's function. In the next tutorial, we'll get into how to create the 3D geometry on which the layers will be based.